BA Geography, Semester 6, Geographic Information System, Lesson 11, Data Display. In the previous chapter, we have discussed about different arrows that are acquiring during the data entry into the GIS system and different tools in editing or in rectifying the errors that are created. In this chapter, we will discuss about how the data is displayed and various elements that are involved in cartography. The main objective of this chapter is that we should understand about the cartographic representation, the types of quantitative maps, map design and map layout. Maps are basic elements in GIS as view, query and analysis data through map. We plot maps to examine the results and of query and analysis, and we produce maps for presentation and reports. As a visual tool, maps are most effective in communicating geospatial data, whether the emphasis is on the location or the distribution pattern of the data. The common map elements are title, body, legend, north arrow, scale bar, acknowledgement and need line or map border. Other elements include the graticule or grid, name of the map projection, insert or location map and data quality information. There is large improvement in data display which is very important in commercial GIS packages. Desktop GIS packages with the geographical user interface are excellent for data display for two reasons. First, the map maker can simply point and click on the graphic icons to create a map. Second, desktop GIS packages have incorporated some design operations such as symbol choices and color schemes into menu selection. Cartographic representation. Cartography is making and study of maps in all their aspects. Maps are divided into thematic, qualitative or quantitative maps. The thematic maps display large distribution pattern of a selected theme such as distribution of population density by country. A qualitative map displays different types of data such as vegetation types, whereas a quantitative map communicates ranged or numeric data such as city population. Regardless of the type of the map, cartographers present the map data to the map reader by using symbols, colors, data classification and generalization. Spatial features and map symbols. Spatial features are characterized by their location and attributes. To display a spatial feature on a map, we use a map symbol to indicate its location and visual variable or visual variables with the symbol to show its attribute. The choice of map symbol is simple for raster data. It is displayed as point, line or polygon. The choice of map symbol for vector data depends on the feature types. Visual variables for data display include hue, value, chroma, size, texture, shape and pattern. The choice of visual variable depends on the type of data to be displayed. The choice of visual variable is limited in the case of raster data. The visual variables of the shape and size do not apply to raster data because the use of the cells. Using texture of pattern is also difficult with small cells. Display options for raster data are therefore limited to different colors in the most cases. Use of color. Because color adds a special appeal to a map, map makers will choose color maps over black and white maps whenever possible. But color is probably the most misused visual variable according to published critics of computer generated maps. The user of color in map making must begin with an understanding of visual dimensions of hue, value and chroma. Hue is a quality that distinguishes one color from other, such as red from blue. Value is the lightness or darkness of the color, with the black at the lower end and the white at the higher end. We generally perceive darker symbols on the map as being more important or higher in magnitude. Also called saturation or intensity, chroma refers to the richness or brilliance of the color. A successful saturated color is pure, whereas a low saturation approaches grey. We generally associate higher intensity symbols with greater visual importance. The first thumb used in the use of color is simple. Hue is a visual variable better suited for qualitative data, whereas value and chroma are better suited for quantitative data. Data classification. All the data and map feature are classified into a number of classes. This process is called data classification. GIS is there are different data classification methods. Equal interval method, which divides the range of data value into equal intervals. Geometric interval method. This method groups data values into classes of increasingly larger interval. Equal frequency, also called as quantile method. This method divides the total number of data value by the number of classes and ensures that each class contains the same number of data value. Mean and standard deviation method. This method sets the class breaks at unit of standard deviation above or below the mean. With changes in the classification method, the number of classes or both the same data can produce different looking maps and different spatial patterns. This is why map makers usually experiment with data classification before deciding on a classification scheme for the final map. Although the decision is ultimately subjective, it should be guided by map purpose and map communication principles. Types of quantitative maps. There are 6 different types of quantitative maps. They are dot map, choropleth map, map graduated symbol map, the pie chart map, a proportional symbol map, the 𝗧-arithmetic map. The dot map shows geospatial data using uniform point symbols, with each symbol representing a unit value. One-to-one dot mapping uses the unit value of 1, such as 1 dot representing one location. But in most cases, it is one-to-many dot mapping and the unit value is greater than 1. The placement of dots becomes a major consideration in one-to-many dot data. The choropleth map is mainly used to represent data derived based on administrative units, whereas map symbolizes with shading. For example, a map showing average population of a country. The derived data are usually classified prior to mapping and are symbolized using color scheme for quantitative data. Therefore, the appearance of the choropleth map can be greatly affected by data classification. Cartography often make several versions of choropleth map from the same data and chooses typically one with a good spatial organization of classes for final map production. The symmetry map is a variation of simple choropleth map. By using statistics and additional information, the symmetric map delineates area of homogeneous value rather than following administrative boundaries. This map is used to be a time-consuming task, but the analytical function of GIS have simplified the map procedure. GIS package such as ArcGIS uses the term graduated color map to cover the choropleth and symmetric maps because both map types use a graduated color scheme to show the variation in spatial data. This map uses different size symbols such as circles, squares or triangles to represent different ranges of values. For example, we can use graduated symbols to represent cities of different population ranges. Two important issues to this map type are the range of the size and the discrete label difference between sizes. Both issues are inextricably related to the number of graduated symbols on a map. A proportional symbol map is a map that uses specific symbol size for each numeric value rather than the range of values. Therefore, one cycle size may represent a population of 10,000, another 15,000 and so on. The chart map uses either pie charts or bar charts. A variation of the graduated circle, the pie charts can display two sets of quantitative data, that is, the circle size can be made proportional to the value such as country population, and the subdivisions can show makeup of the value such as the racial composition of the country population. Bar chart uses vertical bars or their heights to represent quantitative data. Bar charts are typically useful for comparing data side by side. The flow map displays different quantities of flow data such as traffic volume and stream flow by varying the line symbol width. Similar to graduated symbol, the flow symbol usually represents ranges of values. Its-arithmetic map uses a system of isolines to represent a surface. Each isoline connects points of equal value. GIS often uses the its-arithmetic map to display the terrain and statistical surface created by spatial interpolation. Typography. Is very important to understand a map, and it is needed for almost every map element. Map makers treat text as map symbol because, like point, align or area symbols, text have many type variations. Using type variation to create a pleasingly incoherent map is therefore part of the map making process. Type variations. Type can vary in the type of face form. A typeface refers to a design character of the type period. Two main groups of typefaces are serif and sans serif. Serif are small finishing touches at the end of the line strokes and which tend to make running text in newspaper and books easier to read. Compared to serif types, sans serif types appear similar and bold. Although it is rarely used in books or other text intensive materials, a sans serif type stands up well on maps with complex map symbols and remain legible even in small faces. Type form variation include type, weight type with upright versus slanted, and uppercase versus lowercase. Font is a complete set of all variants of a given typeface. Font on a computer are those loaded from the printer manufacturer and software packages. They are usually enough for mapping processes. If necessary, additional font can be imported into GIS packages. Type can also vary in size and color. Type size measures the height of the letter in points within 72 points to an inch. Printed letter look smaller than what they are point size suggests. The point size is supposed to be measured from a metal type block which must accommodate the lowest point of the defender to the highest part of the sender. But no letters extend to the very edge of the block. Text color is a color of the letters. In addition to the colors, letters may also appear with drop shadow, halo or fill pattern. Design of a map. Like graphic design, map design is a visual plan to achieve a goal. The purpose of the map design is to enhance map communication, which is particularly important for thematic map as well as designed map is balanced, coherent, ordered and interesting to look at, whereas a poorly designed map is a confusing and disoriented. Map design is both an art and a science. They may not be clear-cut right or wrong design for a map, but they are better or more effective maps and worse or less effective maps. Map design overlaps with the field of graphic arts, and many map design principles have their origin in visual perception. Cartographers usually study map design from the perspective of layout and visual hierarchy. Layout or planner organization deals with the arrangement and composition of various map elements. Major concern with layout are focus, order and balance. A thematic map should have a clear focus, which is usually the map body or a part of a map body. To draw the map reader's attention, the focal element should be placed near the optical center, just above the map geometric center. The focal element should be differentiated from other map element by contrasting line with texture, value, detail and coloring. After viewing the focal element, the reader should be directed to the rest of the map in order fashion. For example, the legend and the title are probably the next element viewer needs to look after the map body. To smooth the transition, the map maker should clearly place the legend and the title on the map, with perhaps a box around the legend and a larger type size for the title to draw the attention to them. A finished map should look balanced. It should not give the map reader an impression that the map looks heavier on the bottom or top or side. But balance does not suggest the breaking down of the map element and placing them almost mechanically in every part of the map. Although in that case, the elements would be in balance, the map would be disorganized and confusing. Map makers therefore should deal with balance within the context of organization and map communication. Cartographers used to use thumbnail sketches to experiment with the balance on the map. Now they use computers to manipulate map elements on a layout page. ArcGIS, for example, offers two basic methods for layout design. The first method is to use layout template. Next template are grouped as general, industry, USA and world. Each group has a list of choices. For example, the layout templates for the United States include USA, USA counties, counterminus USA and 5 different regions of the country. The idea of using a layout template is to use a built-in design option to quickly choose a map. Second option is to open a layout page and add map elements one at a time. ArcGIS offers different frame elements like title, text, legend, north arrow, comma, scale bar, picture and object. These framed elements, when placed on a layout page, can be enlarged, re-reduced or moved around. Other map elements that ArcGIS offer are insert box, map border and graticule. A layout design created by the second option can be saved as template for future uses. Regardless of the method used in layout design, the legend deserves special consideration. The legend includes description of all the layers that make up a map. For example, a map showing different classes of the cities and roads in a state require a minimum of 3 layers, that is, one for city, one for road and one for state boundaries. As a default, these descriptions are placed together as a single graphic elements, which can become quite lengthy with multiple layers. A lengthy legend presents a problem in balancing a layout design. One solution is to divide the legend into 2 or more columns and to remove useless legend description, such as description of an outline symbol. Another solution is to convert the legend into graphics and regroup the graphic elements in the layout. Visual hierarchy is a process of developing a visual plan to introduce 3D effect or depth of a map. Map makers create the visual hierarchy by placing map elements at different visual levels according to their importance to the map purpose. The most important element should be at the top of the hierarchy and should appear closest to the map reader. The least important element should be at the bottom. A thematic map may consist of 3 or more levels of visual hierarchy. The concept of visual hierarchy is an extension of the figure-ground relationship in visual perception. The figure is more important visually, appears closer to the viewer, has form and shape, has more impressive colors and has meaning. The ground is a background. Cartographers have adopted the depth cues for developing the figure-ground relationship in map design. Probably the simplest and yet most effective principle in creating a visual hierarchy is interposition or superimposition. Interposition uses the incomplete outline of an object to make it appear as though it is behind another. Example of interposition abound in maps, especially in newspaper and magazines. Continents on a map look more important or occupy a higher level in visual hierarchy if the lines of longitude and latitude stop at the coast. The map title, a legend or an inset map looks more prominent within a box with or without the drop shadow. When the map body is deliberately placed on the top of the neat line around a map, the map body will stand out more. Because interposition is so easy to use, it can be overused or misused. A map looks confusing if several of its elements compete for the map reader's attention simultaneously. Subdivisional organization is a map design principle that groups map symbols at primary and secondary levels. According to the intended visual hierarchy, each primary symbol is given a distinctive hue and the differentiation among the secondary symbol is based on color variation, pattern or texture. For example, all topical climate on the climate map are shown in red and different tropical climate are distinguished by different shades of red. Subdivisional organization is most useful for map with many map symbols such as climate, soil, geology and vegetation map. Contrast in a basic element in map design important to layout as well as to visual hierarchy. Contrast in size or width can make the state outline look more important than county boundaries, and larger cities look more important than smaller ones. Contrast in color can separate the figure from the ground. Cartographers often use a warm color, example orange to red, for the figures and a cool color blue for ground. Contrast in texture can also differentiate between the figure and ground because the area containing more detail, a greater amount of texture tends to stand out on the map. Like the use of interposition, too much contrast can create a confusing map appearance. For instance, if the bright and green are used side by side as area symbols on a map, they appear to vibrate. A tool that many GIS packages offer for data display is called transparency, which controls the percentage of a layer that is transparent. Transparency can be useful in creating a visual hierarchy by toning down the symbols of a background layer. Suppose we want to superimpose a layer showing major cities on the top of the layer, showing the rates of population change by the county. We can apply transparency to the county layer so that the city layer will stand out more. Map output. GIS users design and make maps on the computer screen. These soft copy maps can be used in variety of ways. They can be printed, exported and the use on the internet used in overhead computer projection system, exported to other software packages or further processed for publishing. Map output is a complex topic. We are often surprised that color symbols from the color printers do not exactly match those on the computer screen. This discrepancy results from the use of different media and color symbols. Data display on the computer screen uses either cathode ray tube or liquid crystal display and LCD. It is used to be that desktop computers use CRT and laptop or portable computer use LCD. But now more desktop computers are also using LCD to take advantage of the thin flat screen. Summary. In this chapter, we understood about different upper graphic representation which helps us to understand the map. Types of qualitative map which helps us in distinguishing and usage of different maps. Map design which helps us in understanding the different aspects that are present in the making of a map. And the map output or the map production where the final copy of the map can be exported into different software packages or computer system.